Hi dears, welcome to my channel. Today we are discussing class 9 third lessons atoms and molecules. What was the second lesson? Is the matter around us pure? Isn't it? There I have asked you three questions. Do you remember? It's a time to answer these questions. The first question was colloid is a dash mixture. Colloid is a heterogeneous mixture is the answer. The second question, ice, water and vapor looks different but they are dash same. Is it by physically or chemically? They are chemically same is the answer. When the light is passed through the water containing few drops of milk, milk scatter light. This phenomena is called dash. This phenomena is called Tyndall effect. Now we are moving. We are moving for the third lesson. The lesson's name is atoms and molecules. Is there any connection with second lesson and third lesson? What was the second lesson? Was the matter pure? Is the matter around us pure, isn't it? The matter is made of particles. The particles are indivisibly separated, small also. They are very minute and we are not able to see. With these particles, the matter is made of. Scientists were looking for by what the matter is made of. So they came into a conclusion that the matter is made of atoms and molecules. That's why they are giving this lesson after the second lesson so that you can learn about the matter much more clearly because they are made of these atoms and molecules. Okay, dears? So there is a connection. You can't feel that you have no connection between these two. Actually, there is a connection. Now, we have to see what an atom is. Before that, we have to go through the theorems, that is, law of chemical combination. We know many substances are formed by chemical reaction, isn't it? So, chemically, some substances are combined to form some other substances. But the law is saying that the mass of the reactants as well as products remains the same. In a chemical reaction, the mass of reactants will be same as the mass of products. That means nothing is created, nothing is destroyed by itself. Okay, the same change in mass will be seen for our reactants as well as products. That is law of chemical combination. Second is law of constant proportion. That means when the elements are combined to form some other things, they remains constant. The proportion of the elements remains constant. For example, we have to consider water. H2O is the formula for it, isn't it? So we know H2O means 2 hydrogen is needed and 1 oxygen is needed, isn't it, ma'am? So we can say 2 atoms of hydrogen and 1 atom of oxygen combined to form what, ma'am? 1 unit of water, isn't it? So if I am having 6 atoms of hydrogen and 2 atoms of oxygen, can it be H6O2? No, it should be H2O. The value will be constant. The proportion of the elements which are combined will be constant or should be constant. So H2O is the only formula for water. So we can write, if 2 atoms of hydrogen, is the thing clear for you? If 2 atoms of hydrogen and 1 atom of oxygen combined to form what? 1 unit of water. In the same way, 6 atoms of hydrogen plus 2 atoms of oxygen, we will not get H6O2. Instead, we are getting 2 units of H2O plus hydrogen, H2. 2 atoms of hydrogen will be left. That means the elements are chemically combined in a constant proportion. This is all about these two laws. Now, from these, the great scientist Dalton, concluded something about the atoms. Okay, atoms are indivisibly smaller particles, tiny particles by which entire matter is made of. Okay, and atoms can be neither be created nor be destroyed. Okay, and the third one, in a particular element, the atom will be constant. That means it will be having the same mass and chemical properties. Chemical properties and the mass of atoms remain same for a particular element. For example, oxygen. If we can't say in oxygen, if we are considering much more oxygen atoms, one oxygen atom is big, one oxygen atom is small, one is having greater mass, one is more having smaller mass. Like the students in the class, can you arrange the oxygen? No. In the class you can say no, some children are so tall, some children are fat, some children are lean, some children are lean. But in the case of oxygen or any atoms for an element, we can't say in that manner. All the atoms will be having same what mass? Same mass as well as chemical properties. Okay, dears. Okay, in the case of different elements, will the atoms having same mass and chemical properties? No. The carbon is much more fatter, much more having weight or mass than hydrogen. So we can't say that all the different elements are having same atomic mass, and like that we can't say. For different elements, the atoms will be having different mass as well as different chemical properties. Okay, dears. Now, as we already told, for a particular element or a particular molecule, the atoms are combined in a particular ratio. The ratio will be constant. That's why I told you initially. In case of water, the formula is H2O. It can't be H3O or it can't be H4O7. Like that we can't change. If oxygen number is much more, if you are able to add, you can't add. Like you are adding coffee. If you are adding sugar to coffee, if the sugar is much more, you can add more, right? Like that you can't add less. Okay? Because it is having a particular ratio. That is water. Formula of water is H2O. It cannot be H3O or H4O2. Like that it should not change. Will not change. And relative number and kind of atoms in the formation of compounds or molecule will be constant. These are the 6 main points which Dalton proposed about the atom. Now we are getting some idea about the atom. What is an atom will be? Atom will be small, much more smaller than that we are able to imagine. That is, its size is about 10 raised to minus 9 meter. That is, in nanometer we are expressing. 10 raised to minus 9 meter is the size of the atom. Okay. Having the size, the radius will be in 10 raised to minus 9 meter. That is, we are expressing it in the form of nanometer. Now we are moving to see the symbols which we can give to the atoms. Have you all seen the periodic table? If you have not seen the periodic table, you should have to see the periodic table now itself, because on the upcoming years or upcoming classes, it will be very valuable. If you know the periodic table very well, you will be what to say, you will be much more fantastic in chemistry. Okay, yes. Okay, now about the symbols. We know initially there were only a few elements or few atoms of these elements were found. By the time Dalton proposed some kind of symbols here. See, hydrogen, it was so small. I told you, hydrogen, the mass is much more less than any other atoms. So he gave in a circle a small dot. It shows that much small the hydrogen is. So he gave that symbol. Oxygen, compared to this hydrogen, it was much more. So in a circle he gave this much will be the mass of oxygen. Based on the mass, he has given some symbols. Phosphorus, this. Have you seen this symbol? Of a cars. In some cars, we can see this kind of symbol. Like the Dalton used to give. But it will be very difficult for us to remember, no? So, Berzelius, a scientist, Berzelius, told that it can be much more better if we are changing the symbols in the form of letters. Okay, you can start with first letter or some first letter and second letter, or first letter or some other letters we can add on, so that it will be much more easy to remember. It's correct only, because it helps us to remember our periodic table much more easier. Say for hydrogen he has given H. Then helium he can't give H again, because hydrogen already given H, and again one H cannot be given for helium, so he considered it helium, He. So he has given it He, like that. So cobalt, CO, copper. So again CU can't be given. So he gave it CU. It depends on the place. The place in which, in the place of Cyprus, the cobalt was first found out. So he gave in the relation with the place from where they are evolved, or from in which place it will be much more seen. Like that, some symbols has been created. For sodium, it is not SO, it is Na, natrium. Then potassium, it is not P. It is for when we are writing P, it is a symbol of phosphorus. It is K, kalium. From K, some Greek or Latin words. From these also they have evolved. They have derived these symbols. Okay, dears. So it will be easy for us to remember. Particular each elements will be having separate symbols. Now, if no, okay, ma'am. If I like to write copper as CO, is it okay? If you are asking, it is not okay, because there is an organization called International Union of Pure and Applied Chemistry. They have to accept. Then only this chemical formula or chemical this symbol will be accepted. So it is accepted by the whole world. So you can't able to change according to your wish. Okay, dears. No, I only meant it. Actually, it is hydrogen. I have written as He. It is not helium. It is actually hydrogen only. In my mind, it was hydrogen. Like that, you can't say, because international science they are how to accept that only this chemical symbols has to become. Initially, I am telling you, dears. Okay. Then about the atomic mass, because atoms are indivisibly small. Why should we consider the mass? But we have to consider mass, because when these atoms are combined chemically, much more compounds or molecules will be formed. By the time this atomic mass will be much more valuable. Okay, dears. So if we are considering the atomic mass, we have to have a standard, isn't it now? For example, if you want to purchase 1 kilogram of apple, 1 kilo of apple, we are going to the market and ask 1 kilo of apple. So what will he do? If he is having the old system of balance, you have seen now some kind of this balance. So he will put some apples over here, and here he will put something, no? Some stone or something like that. 1 kilo. Then iron piece, it will be having marked as 1 kilo. 1 kilo is the standard. He will keep it, and here he is comparing the apple whether it is balanced or not. If it is not balanced, if he want to add, he will add more, or if much more is there, he will take. Isn't it? There is something to be balanced. So like that, for considering the atomic mass also, there should be something for comparing, isn't it? Your marks, teacher is comparing, your mothers are comparing with what? First rank student, how much mark he is having? How much mark you are having? She is comparing. No, ma, the paper was very bad, because every question was from out of syllabus. So, first rank student also didn't get good marks. Out of 100, he got 60, and I am getting 52. So, she will be, okay, no problem, because 60 is the highest mark. Like that, comparison is there in every field, right? No? So, there should be some kind of comparison. Initially, they have taken oxygen for comparing. Okay, oxygen, because oxygen used to go combined with almost all atoms. All the atoms. So, they felt oxygen is the good thing for comparing. But finally, they found it is much more difficult for considering oxygen. Instead of that, they have taken carbon 12. Isotope of carbon, that is carbon 12 as the standard. Based on that, they are comparing all the rest of all atoms with that. Okay, dears. They are taking what is atomic mass unit, that is AMU. We are representing it as mu. Every atoms are having its own atomic mass unit. How we are getting is, we are comparing this atomic mass with that of 1/12 of the mass of carbon atom. We are not comparing it with exactly one carbon atom. Instead, we are comparing it with 1/12 of the mass of carbon atom. So we are comparing it with that. So we are getting some units, something. See, for hydrogen is having 1 unit. 1 mu. Okay. For carbon it will be 12 mu. Why 12 mu? We are comparing it with 1 by 12th of the mass of carbon atom. So carbon will be 12 into 1. So it will be 12 only, isn't it? Oxygen, it is much more heavier than carbon. So it is having 16. Like that it will be moving. Okay, dears. Compare having this thing in mind, we are going to do the calculations in the higher classes. Okay, dears. Now we are moving to see. We are moving to see what, ma'am? We are moving to see about molecules. What are molecules? Molecules. We know about the atoms now, isn't it? They are very small, negligibly small. They are indivisible particles. All these we know. But this atom is having some minority. You know what is that? Atom is not able to exist by itself. They are not able to exist by itself. They need something. Some atoms, some support, isn't it? Some support is needed for the atoms. So what we are coming to that, they are molecules. The atoms may combine together to form molecules. Now we are moving to see about the molecules, isn't it? As we know, atoms are that much indivisible particles. But the speciality of the atom or the minority of this atom is the atom is not able to exist independently. There should be some support for the atoms to exist. When one atom is combined with another atom, we are saying it as molecule. Okay, dears. So there are some elements like argon, krypton, xenon. All these are much more stronger. No need of any others for me to exist. Like that, they will say. So they will exist as single atom itself. They are considering as a monoatomic molecule because one mono means one. Monoatomic molecules because they are existing as single atom. But we are considering it as molecule. Okay, dears. There are some other elements like oxygen. Okay, hydrogen. All these are not able to exist as single atom. Oxygen atom, as an atom, it is not able to exist. So it will combine with another atom of oxygen to form O2 as oxygen molecule. O2 is the oxygen and a molecule. So we are saying it as diatomic molecules. Okay, dears. And hydrogen also diatomic. What about phosphorus, ma? Phosphorus, if phosphorus is crying, I am not able to exist independently. So one more phosphorus came. Okay, can we exist? No, I am not able to exist independently. So one more phosphorus came. Still I am not able. So 4 phosphorus atoms should combine. Okay, it's called tetraatomic molecule. Okay, dears, like that the molecules will be seen. So can you say what are molecules? Molecules are the smallest particle which can have independent existence. Okay, and they will show the property of the substance. The property of the molecule, the properties will be shown by this molecule. Is oxygen. The property of oxygen will be shown by this oxygen molecule. The property of hydrogen will be shown by this hydrogen molecule. Like that, it will show the properties. Okay, dears. They are charged. Are they charged particles? No, there is no charge in it. They are neutral particles. There is no charge, positive or negative charge is not there on the top of it. As the crown, there is no charge again. They are neutral. Okay, dears. So molecules can be, as I said, they can be same type. It can be made of same type of atoms and different types of atoms. If they are made of same type of atoms, we are saying it as monoatomic, diatomic, triatomic, tetraatomic, like that. Same atoms will be combined. For example, oxygen, I told you, diatomic. Phosphorus, tetraatomic. Then sulfur, polyatomic. All these we can say. When the molecules of different atoms are combined, is it possible? Yes, it's possible. For example, of water. Water is a molecule, isn't it, ma? Water, hydrogen and oxygen will be combined. Okay. For molecules of compound, they are also formed and they will be having independent existence. One molecule of water will show all the properties of the water. They are able to exist independently also. Is it clear, dears? Now we are moving to see ratio by mass of these. It is very, very important. It is is very, very important. It is a serious matter. Till now we were dancing, we were enjoying. But now we are coming to the serious part, isn't it? Yeah. That is ratio by mass. What is this ratio by mass? In the case of water, the ratio by mass is 1:8. How did you get it? No, ma'am, we have to learn by heart. It is not the way to learn. I will teach you how we are arriving this formula, this ratio. That is, ratio by mass means the water molecule hydrogen will be 1 in that. If the hydrogen is in the ratio of 1, the oxygen will be in the ratio of 8. That's it. Okay. It is able to be calculated if we know what? Atomic mass. Atomic mass of hydrogen as well as oxygen. What is the atomic mass of hydrogen, ma'am? I told you in the carbon, we are comparing with the carbon 12 atoms. We are saying, isn't it? Hydrogen is having the mass 1. Oxygen is having the mass 16. Do you remember? I told compared to hydrogen, it is much more bulky. So, how many hydrogen are there? 2. 2 atoms of hydrogen. 1 is 2 plus 16. How many oxygen atoms are there? 16 into 1 only, isn't it? 16 is equal to what? Is equal to 2 is to 2 is to 16. It's not adding, ma. 1 into 2 is to 16. So we will get as 2 is to 16. How did you get 1 is to 8? Then we are cutting, ma, by 2. We are getting 1. Here 8. 1 is 2 is the ratio. Is it clear? It is the way you are getting. Then NH3. Ma'am, all these things are very difficult for me to learn. If you are having a feeling, that also there is a solution. See. This. Have you ever seen? Yes, you have all seen it, right? You are good children, you have seen it. Is it clear, Kanna? Nitrogen, where the nitrogen is? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. What is the atomic number of nitrogen? Atomic number of nitrogen is 7. The atomic mass of nitrogen is 7 into 2, that is 14. Okay, it will not be worked for all the atoms, but most of the atoms it will be working. For the working atoms we can play, right? Okay, that's it. So nitrogen 7 atomic number and atomic mass will be 7 into 2, that's 14. Okay, NH3, hydrogen, what is the atomic number? Atomic number is 1. Atomic mass is 1. Isn't it? Is it working for hydrogen? No. 1 into 2 should be 2. But for hydrogen it is 1 also. 1 only. So nitrogen 14 is to hydrogen 1 into 3. That's equal to 14 is to 3. Is it clear? Is it correct? Yes. Then about carbon dioxide. Carbon, what is the atomic number, ma? 1, 2, 3, 4, 5, 6, 6. 6 is the atomic number. So atomic mass will be what? 6 into 2? 12. It's correct. 6 into 2, 12. 12 is the atomic mass. 12. Is there any carbon more than 1? No, only 1 carbon. So 12. Is to oxygen. What is the atomic mass? We have already studied is 16. 16 into 2. Why 2? Because see O2. So 2 is equal to what? 16 into 2 what, ma? 32. 12 is to 32. Then how did you get as 3 by 8? We are cutting it. 4, it is going in 4 table as 3. It's going in 4 table again as 8. So we are getting the ratio as 3 by 8. By this way we are able to calculate ratio by mass of different compounds or different molecules. Okay. Now we are moving for the second and next part, that is important one, that is ions. What are ions? Now we are moving to see about ions. Ions are charged species. It can be metals as well as non-metals, but they are charged. There is a positive or negative charge on the head of it. Okay, guys. How can we identify whether it is positive charge or negative charge? By seeing whether it is metal or non-metals. Metals means, here see Gana, here all these are considered to be metals. All these can be considered to be metals. Then here also aluminium, gallium, indium, thallium. All these here can, up to this extent we can say it as metals. See, ma, nitrogen, gallium, tin. See, in the case of metals, they are having the tendency to lose electron. They have the tendency to lose electron, like our Dana, Veera, Shura, Karna. Okay? They are having electrons, but they are having the tendency to lose it. Okay, so they will be losing the electron and they will be having positive charge. How the positive charge is coming? For the charged, for the neutral atom, there will not be, for the neutral atom consider, for every negative charge there will be positive charge. We know electrons are having negative charge and the protons in the nucleus will be having positive charge. For every electron there should be a proton. So positive, negative. Positive, negative. We can say it is neutral because for one positive it is one negative. When these metals are there, they will be able to lose one electron. It will give one electron. So what will happen? Positive charge will be remain, isn't it? So we are saying it as it is having positive charge. For example, sodium Na plus. Because it is having the tendency to lose one electron and getting positive charge on this head. Okay. So this is about metals. When we are considering non-metals, what will happen, ma? In the case of non-metals, here positive, negative is there, but it is having the tendency to accept the electron. Non-metals are having the tendency to take electron which the metals are giving. For example, oxygen. It will be the tendency to take 2 electrons, not only 1 electron. It will be the tendency to take 2 electrons. So, oxygen will be in the form of O2 minus. How many electrons it is taking? 2 minus. If negative charge is present in the ion, we are saying it as anion. Okay, so oxygen is an anion or a cation. Negative charge is there on the top of it. So we are saying it as oxygen is anion. When the positive charge is there on the top, what will we say? We are saying it as cation. Okay, for your convenience, there will be confusion for you, isn't it? Anion, what is a negative or positive? You don't know. Like that, if you are having confusion, I will teach you in a easy manner. See, A, B, C, D, like that it is moving. No, A, after that B, then only C is coming. Like that in the case of number also, number system, negative charge, 0, positive charge, isn't it? Negative charge negligibly, minus 1, minus 2 is negligibly small, then 0, much more big, then positive charge. So, anion means negative charged. Okay, then after A, then B is coming, then only C is coming. When C is coming, it is much more higher, so we are getting positive charge. Anion, negative charge, cation, positive charge. Don't make a confusion over it. Okay, yes? And negative, cation, positive. Now, see, by this way also, there are many compounds formed. Okay, so how the compounds are formed? Compounds are formed depending on the combining capacities of the metals. Combining capacities of the metals as well as non-metals. How will we see the combining capacity? That is, it is about the octet rule. That is, electrons on the outermost shell of the nucleus will be having, if there is much more extra electron is there, this atom or the molecule or the element will leave it. For example, sodium. See, our periodic table again coming. Lithium, beryllium, boron, carbon, nitrogen. Up to this extent has been gone. Then here, when we reaches this noble gas configuration, we are saying this compound is stable. Then Na plus is the next one, isn't it? So it is having the tendency to attain neon configuration. So it is having one more electron extra. Yeah, no need of this electron because I want to leave this electron to make myself in a stable configuration. Who is saying? Sodium is saying. So sodium loses, no need of this extra electron. It is losing it. Okay. So this is combining capacity. So it is having the tendency to lose one electron. Who you want this electron, ma'am? Fluorine, chlorine, like that it will be wanting. But it will want it because it want to have the argon configuration. One more electron is needed. If anyone is giving me one more electron, I can become the stable configuration of argon. Like that it will be having. So if anyone is giving, it will accept. Okay. This is what, ma'am? This is the combining capacity. So sodium is giving one electron and that negative electron will be taken by chlorine to make sodium chloride. So the compound will be stable. Is it clear? Some bulb is glowing. Is there any bulb glowing over there? So it is the way the metals have the tendency to lose electron while non-metals have the tendency to accept this electron. So in the case of magnesium, how many electrons it will lose? Here it is coming after sodium. Here one electron it lose. Here magnesium will lose 2 electrons. When the 2 electrons is lost, it will be having this. Which configuration, ma? It will be having neon configuration. 2 electrons are extra for me. It will lose 2 electrons. Who will accept this one? Who will accept? If this will accept 1 electron, it needs only 1 electron. Here this series needs 2 electrons because when it is getting 2 electrons, it will reach neon configuration. So oxygen will take this 2 electrons directly. So magnesium and oxygen to form MgO, magnesium oxide, or magnesium sulfide, MgS, like that it will be having. It will be forming. Okay, by this way what will happen? These compounds are formed. Okay, valency of the charge should be balanced. 2 minus, magnesium will be having 2 plus and this oxygen will be having 2 minus. Oxygen will be having 2 minus. So what will happen? It will be balanced. Second one is metals and non-metals are combining. Metal should be in the left side and non-metal should be in the right side. You should not write OMG or you should not write Cl2Mg. Like that you should not write. The metal should be in the front and non-metal should be in the back. MgO or MgSCaO, like that we can write. The third one is compound can bond with polyatomic ion. Not only single atom, much more atoms, like that is polyatomic ions also can be formed. OH minus. OH is having the tendency, it is having negative charge. It needs 1 electron. Na is ready to give 1 electron and it will be accepted by OH to form NaOH. Like that MgOH twice. Okay, magnesium gives 2 electron. OH needs 1 electron. So how many OH is needed? 1 electron is given by magnesium, which is taken by 1 OH, and another electron which is given by the same magnesium will be taken by another OH to form MgOH twice. Like that the things are formed. Okay dears. Now for this also ratio by mass is important. Calcium oxide, ma. Calcium oxide again periodic table dears. Calcium having 20 is the atomic mass. So atomic number, so what will be the mass number? Atomic mass will be 20 into 240. It is corrected here. Here it is 14. And oxygen we know it is 16. So 40 is to 16 is the ratio by mass. When we are cutting it, we will get 5 is to 2. Similarly for magnesium sulfide, 24 is to 32. Because magnesium is having atomic number 12, atomic mass will be 24. And sulfur will be having what, ma'am? Sulfur 16. So its atomic mass is 32. 3 is to 4 is the ratio. Like that we can form what, ma'am? Compounds. Compounds can be formed by this way. Now we are moving to see how to write the formula of it. Okay, how we can write the formula? As we know, hydrogen atom combined with oxygen to form H2O. How can we write it easily? It is the way. Okay, tricky way. Okay, we know when the two atoms combine, what will happen? A small compound is a molecule is formed. We are considering it as binary compound. Okay, that is a simple one we have to learn. Now we are moving to see the formula of it. How we can write the formula? For example, we are considering the elements. First we are writing the elements. Then their valencies we are writing downside. And then we are crossing over. How? Is it clear? It's not clear. I know. See, Kana, hydrogen. Hydrogen, what is the hydrogen valency, ma? What is the valency of hydrogen, ma? Where is the periodic table? Yes, periodic table we are having. Hydrogen valency 1. Why? The hydrogen is able to release or to donate 1 electron. So it is having the valency 1. Okay. Hydrogen, we are writing the valency 1. Then we are writing oxygen. Oxygen, I told you, Nama. Oxygen is having the tendency to reach neon configuration. So it needs what, ma? 2 electrons. So we are writing the valency of oxygen as 2. Or we can write it as 2 minus. 2 minus also we can write. Then what we are doing? We are crossing over. We have written hydrogen 1. oxygen 2. Then we are crossing over hydrogen here and here. So hydrogen 2 oxygen H2O. This is the way we are able to find. Can we write one more? Here I have written magnesium. Magnesium in which it is alkaline earth metals. It is having the tendency to give 2 electrons and to become 2 positive, 2 plus. Magnesium is having 2 plus. Okay, magnesium I am writing, and below it I am writing 2 plus. Okay, then oxygen, again we are writing oxygen. Oxygen is having the tendency to accept 2 electrons to form what one? Neon configuration. So 2 minus. Oxygen 2 minus. This we are exchanging, interchanging Mg2O2. Mg2O2 is both are same now, so we are removing it. 2 is not needed. If there is change in number, we are writing as such. If the number is same, we are writing as MgO. Okay. Now the case of polyatomic compounds. See, CO3 and Na. Sodium is having what ma? Sodium is in the alkali. Alkali metals having the tendency to give 1 electron and to be 1 positive. And Na have the tendency. What is the valency of the sodium? 1. Valency of sodium is 1. Then CO3 is the tendency to accept 2 electrons. It is having the tendency to accept 2 electrons. So it is having 2 minus. So we are interchanging it. We are writing as Na2CO3. Is that clear? Now it is getting clear for you, right? We are writing the constituent elements and the valence is below. Then we are cross-overing it. Here will come to there and there will come to here, like that. Okay. If you are exchanging your class teacher, this class teacher will go there and that class teacher will come here, like that. It is okay. So crossing over. Now it is the way we are able to write the chemical formula. Now we are moving to see what is the molecular mass. Till this extent we have seen the atomic mass of the various elements. Now we have make a molecule also. How we are able to write the formula of the molecule. Now we have to find the molecular mass. How we can find the molecular mass? It is nothing than adding the atomic masses. For example, H2O. Simple H2O. It is having how many hydrogen atoms? 2 hydrogen. And how many oxygen? 1 oxygen. So atomic mass of hydrogen is what? 1. Atomic mass of hydrogen is 1 and 2 hydrogen is there. So 1 into 2 becomes what? 2. Then atomic mass of oxygen is, we all know from the beginning itself, ma'am is saying it is 16, isn't it? 16. So 16 plus 2, what will be that? It is 18. 18 mu is what, ma? It is the molecular mass of water. Is it easy? It's easy, I think. Then they are saying a bigger comma that is HNO3, nitric acid, HNO3. Hydrogen, no need of worrying. The same thing. Hydrogen, what is the atomic mass? 1. We know. Nitrogen, what is the atomic mass? Nitrogen, where is the periodic table? See, your periodic table is needed. No, you know it. Nitrogen is having the atomic number 7. Atomic mass 7 into 14. So 14. Oxygen, we know it is 16. 16 into 3. Why? Because 3 oxygen atoms are there. So 1 plus 14 plus 16 into 3. What is the 16 into 3? Who knows? 48. Isn't it? Yes. 1 plus 14 plus this 48 will give you 63. I think my calculation is correct. Okay. Then by this way we can be able to make this molecular mass also with the help of this atomic mass. Now you have to know formula unit mass. Formula unit mass, the name is different here. The thing is same. That is, it is easy because in the case of this charged ions, that is anions and cations. For example, sodium chloride is made by what, ma? Na plus and Cl minus. In the same form, this is the same form of forming molecular mass. Molecular mass of this NaCl is atomic mass of sodium plus atomic mass of Cl. Chloride, like that. Here they are saying calcium chloride. Calcium atomic mass is calcium is what, ma'am? Here atomic number is 20 and atomic mass is 40, isn't it? 40. Chlorine. What is the atomic number of chlorine? Atomic number of chlorine is 17. Atomic mass is 35.5. Okay, 35.5 is the atomic mass. So we can't say that it should be 30. It should not be 35.5. I told you, yeah, for every atoms it is not the twice of it, atomic mass. For something it will be changing. So some elements it will be changing, different. It will be different. So we should know that for chlorine it is 35.5. 2 into 35.5 plus 40 will give you 111 nu. This is what? This is the formula unit mass. Now we have finished full thing, isn't it? What all things we have learned about the indivisible particles called atoms. Atoms, about the properties of atoms, specialities of atoms we have seen. Then what are the symbols? How we are representing this dot, hydrogen dot, oxygen bulky, like that. Do you remember? Then they came into the formulas. No, they came the symbols by letters, isn't it? Letters. Then we have gone for ratio by mass, isn't it? Atomicity we have found out there. Now, then we have gone for the molecules. Molecules, what are molecules? How the molecules are formed? What is the specialty of the molecule? Then we have gone for ions, isn't it? Ions. The molecules formed by compounds also we have gone through. Then about ions, then charged species. At last we have gone for the finding out the molecular mass, isn't it? It's the time for. Dears, this is the question time. Be ready for the questions. Atomic mass of sodium is dash. Atomic mass of sodium is dash. Second one, simplest compound formed by two elements are called dash. Simplest compound formed by two elements are called dash. And the third one, valency of OH is dash. OH, valency of OH is dash. Thank you, dears.